So we are given that if a plus ib equals to root of 1 plus I divided by 1 minus I, prove that a square plus b square equals 1. So this question is on complex number. And this will not be the first time that I will make video on complex number. That is, we are given a plus ib equals to the square root of 1 plus I, then divided by, so we are dividing by 1 minus I. Now in this case, what we are going to do here is that, so we are going to square both sides. We square this side and we square the other side. So by squaring both sides, because we have to show that a squared plus b squared equals 1. That is what we are required to show there. Then we have a plus ib raised to power 2 equals to square root of 1 plus I divided by 1 minus I. Then we've squared the right hand side, we are going to, and the left hand side, we are going to square the right hand side as well. So square of this. Now, the square root and the power of 2 will cancel out. Then when you square this, we have a times a plus ib times a plus ib. So in this case, we have I, that is 1 plus I here, divided by 1 minus I. So when you open bracket here, so let's expand it. We have a square, a times iab, then you are going to have, that is a times ib, you are going to have a iab. Then the same thing applies here. Ib times a, you are going to have iab. So you are going to have 2 of it. That will be plus 2 iab. Then ib times ib. I times I, don't forget, I is square root of minus 1. When you square I, you are going to have square root of minus 1 raised to power 2. So which is equal to minus 1. That means I times I will be minus 1, b times b will be b squared. That will be minus b squared. Equals, now this side, let's represent this side. So that if we are going to represent by multiplying by the conjugate, multiply by 1, here we are having minus I, then it will be 1 plus I, then divided by 1 plus I. So multiplying by the conjugate. Now in this case, 1 times 1 will be 1. So 1 times I will be I, then I times I will be I. That will be I plus I will be 2I. Then I by I will be minus 1. So divided by 1 by 1, 1. Then the middle term will cancel out. The middle terms, 2 middle terms will cancel out because we are having difference of 2 squares here. Then I times I will be minus 1. Minus 1 times minus 1, that will be plus 1. So minus will cancel minus, we have 2I divided by 2. 2 cancel out. That implies that a squared plus 2iab minus b squared equals to, we have I there. So therefore, we are going to equate in the like terms on both sides. So the terms in I will equate together, and the constant term will equate together. That means a squared minus b squared equal to 0, because there is no term in real number on the other side. There will be 0 here. So then the complex terms on both sides we are going to equate together. That means 2iab equals to I. When we divide both sides by I will cancel out. So we have 1. So therefore, equation 1, label this one to be equation 1. Then the other equation we have, that will be 2ab equals to 1, equation 2. From equation 1, from 1, a squared equals to, that is a squared minus b squared equals to 0, implies that a squared equals b squared, which implies that a equals to b when you take the square root on both sides. So therefore, a equals to b, coming to this from equation 2. If a equals to b, we can substitute for a or b. Then we have 2a, then multiply by b. B is the same thing as a. In place of a, we use, in place of b, we use a there in this equation, equals to 1. That means we have 2a times a squared equals to 1. Divide both sides by 2 by 2. It implies that a squared equals to 1 over 2. If a squared equals to 1 over 2, definitely b squared will also be 1 over 2. That is, we have a squared equals to b squared, which is 1 over 2. Coming to this, so therefore we have a squared plus b squared equals to 1 over 2 plus 1 over 2, which is 1. So half plus half equals 1. So we have 1. That is what we are required to prove. We have half plus half equals 1. And this is our answer. Please like, comment, and share. Thank you.